Using two cables, specifically a 12-3 nm cable and a 12-2 nm cable, is an acceptable method for wiring a heat vent light fixture with a night light when a single 12-5 nm cable is not available. The 12-3 nm cable will typically carry the power for the fan, the heat, and the light, while the 12-2 nm cable will provide power to the night light. When connecting the wires at the fixture, each hot wire from the 12-3 nm cable connects to its corresponding terminal on the fixture. This means the black wire 1 goes to the fan terminal, the black wire 2 goes to the heat terminal, and the black wire 3 goes to the light terminal. The white wire from the 12-3 nm cable is connected to the neutral terminal on the fixture. Because the white wire in the 12-2 nm cable will be used as a hot wire for the night light, it must be re-identified with black tape or another permanent marking to indicate that it is carrying a live voltage and is not a neutral conductor. Once re-identified, this wire is connected to the night light terminal on the fixture. The ground wires from both the 12-3 nm and the 12-2 nm cables are connected to the ground terminal on the fixture. It's important to make sure all connections are secure, using wire connectors appropriate for the wire gauge and application. All work must meet local electrical code requirements. This method adheres to the National Electrical Code, which permits the use of multiple cables to supply power to a single outlet or fixture, provided that all conductors of the same circuit are run together in the same raceway cable, or otherwise are in close proximity. The requirement to re-identify the white wire used as a hot conductor comes from the NEC, which states that a conductor with white or grey insulation can only be used as a neutral or grounded conductor unless it is permanently re-identified at both terminations. The NEC addresses conductor identification in Article 200.6. This section details the requirements for identifying grounded conductors, which are typically white or grey, and ungrounded conductors, which can be any color other than white, grey, or green. If a white or grey wire is used as an ungrounded conductor, it needs to be re-identified by painting or wrapping the terminal with a permanent color other than white, grey, or green. Usually black electrical tape is used for this purpose. For proper and safe electrical installations, it is essential to consult the NEC and local electrical codes to make sure the work meets all requirements. Local codes can be more restrictive than the NEC, so it's important to check with the local authority having jurisdiction, or OJ, to make sure the installation is compliant. It is important to use the correct size conductors for the circuit. In this case, 12 American wire gauge, or AUG, copper conductors are being used, which are typically protected by a 20 amp circuit breaker. The ampacity of conductors is covered in NEC Table 310.15b16. This table provides the allowable ampacities of insulated conductors rated up to and including 2000 volts. The ampacity of a conductor depends on its insulation type, its size, and the ambient temperature. For example, a 12 AWG copper conductor with type THHN insulation has an ampacity of 30 amps when the ambient temperature is 30 degrees Celsius. However, the overcurrent protection device for this conductor is limited to 20 amps, as specified in NEC section 240.4d. This section provides the requirements for overcurrent protection of conductors. It states that conductors must be protected against overcurrent in accordance with their ampacities, as specified in Table 310.15b16, unless otherwise permitted or required in 240.4 through G. For 12 AWG copper conductors, the overcurrent protection device cannot exceed 20 amps unless one of the exceptions in 240.4b through G applies. It is important to choose the correct size overcurrent protection device to protect the conductors from overheating and causing a fire. It is also important to follow all NEC requirements for box fill. Box fill refers to the maximum number of conductors, devices, and fittings that are permitted in an electrical box. The NEC specifies the requirements for box fill in Article 314.16. This section provides the rules for calculating the volume of an electrical box and the number of conductors, devices, and fittings that are permitted in the box. The volume of the box is determined by its dimensions, and the number of conductors, devices, and fittings is determined by their size and type. For example, each conductor that originates outside the box and terminates inside the box counts as one conductor. Each conductor that passes through the box without being spliced or terminated counts as one conductor. Each equipment grounding conductor entering the box counts as one conductor. Each device, such as a switch or receptacle, counts as two conductors. Each fitting, such as a wire connector, counts as one conductor. The total volume of the box must be sufficient to accommodate all of the conductors, devices, and fittings. If the box is overfilled, the conductors can overheat and cause a fire. It is also important to use the correct type of wire connectors. Wire connectors are used to join two or more conductors together. There are many different types of wire connectors available, each designed for a specific purpose. Some common types of wire connectors include wire nuts, push-in connectors, and crimp connectors. Wire nuts are the most common type of wire connector. They consist of a plastic cap with a threaded metal insert. The conductors are twisted together and then inserted into the wire nut. The wire nut is then tightened to secure the conductors together. Push-in connectors are a newer type of wire connector that is becoming increasingly popular. They consist of a plastic body with spring-loaded contacts. The conductors are simply pushed into the connector, and the spring-loaded contacts make a secure connection. Crimp connectors are used to join conductors together by crimping them with a special tool. They are often used in automotive and marine applications. It is important to choose the correct type of wire connector for the application. The wire connector must be rated for the voltage and amperage of the circuit. It must also be compatible with the type of conductors being used. For example, some wire connectors are only approved for use with copper conductors, while others are approved for use with both copper and aluminum conductors. It is also important to make sure the wire connector is properly installed. The conductors must be properly stripped and twisted together. The wire connector must be tightened to the correct torque, and the wire connector must be protected from moisture and corrosion. When working with electricity, it is important to take the necessary safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools and equipment. Wear safety glasses and gloves. And never work on electrical equipment when you are wet or tired. If you are not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous, and it is important to take the necessary precautions to protect yourself and your property. Furthermore, it is crucial to properly ground the electrical system. Grounding provides a low impedance path for fault current to flow back to the source, which trips the circuit breaker and de-energizes the circuit. This helps to protect people and equipment from electrical shock and fire. The NEC requires that all electrical systems be properly grounded. The grounding system must consist of a grounding electrode, a grounding electrode conductor, and equipment grounding conductors. The grounding electrode is a metal rod, pipe, or plate that is buried in the ground. The grounding electrode conductor connects the grounding electrode to the electrical panel. The equipment grounding conductors connect the metal parts of electrical equipment to the grounding system. This includes the metal enclosures of electrical panels, circuit breakers, and receptacles. The equipment grounding conductors provide a path for fault current to flow back to the source if there is a fault in the electrical equipment. It is important to use the correct size grounding conductors. The size of the grounding conductors is determined by the size of the circuit conductors. The NEC provides tables that specify the minimum size grounding conductors for different size circuit conductors. It is also important to properly bond all of the metal parts of the electrical system together. Bonding is the process of connecting all of the metal parts of the electrical system together to create a continuous electrical path. This helps to prevent voltage differences between the metal parts, which can cause electrical shock. Bonding is typically accomplished by using bonding jumpers. Bonding jumpers are short lengths of wire that are used to connect the metal parts of the electrical system together. For example, bonding jumpers are used to connect the metal enclosures of electrical panels, circuit breakers, and receptacles together. Bonding jumpers are also used to connect the metal water pipes to the electrical system. This helps to ground the water pipes and prevent them from becoming energized. It is important to follow all NEC requirements for grounding and bonding. Improper grounding and bonding can create a dangerous electrical hazard. In addition to grounding and bonding, it is also important to use ground fault circuit interrupters, or GFCIs. GFCIs are devices that protect people from electrical shock. They work by monitoring the current flowing through a circuit. If the current flowing through the circuit is not equal to the current returning to the circuit, the GFCI will trip and energize the circuit. This can happen if a person comes into contact with a live wire. The GFCI will trip before the person is seriously injured. The NEC requires that GFCIs be installed in certain locations such as bathrooms, kitchens, and outdoor areas. GFCIs are also required for receptacles that are located near water. It is important to test GFCIs regularly to make sure they are working properly. GFCIs can be tested by pressing the test button on the device. If the GFCI trips, it is working properly. If the GFCI does not trip, it should be replaced. When installing electrical wiring, it is important to follow all NEC requirements for cable installation. The NEC specifies the requirements for cable support, cable protection, and cable routing. Cables must be supported at intervals specified in the NEC. This helps to prevent the cables from sagging and becoming damaged. Cables must also be protected from physical damage. This can be accomplished by running the cables through conduit or by using cable guards. Cables must be routed in a safe and accessible manner. They should not be run through areas where they are likely to be damaged. They should also be run in a way that allows them to be easily inspected and maintained. It is important to use the correct type of cable for the application. There are many different types of cables available, each designed for a specific purpose. Some common types of cables include NM cable, UF cable, and THHN wire. NM cable is non-metallic sheath cable. It is the most common type of cable used in residential wiring. UF cable is underground feeder cable. It is designed for use in wet locations such as underground. THHN wire is thermoplastic high heat resistant nylon coated wire. It is commonly used in conduit. It is important to choose the correct type of cable for the voltage and amperage of the circuit. It is also important to choose a cable that is suitable for the environment in which it will be installed. For example, UF cable should be used in wet locations, while NM cable can be used in dry locations. Furthermore, consider the importance of arc fault circuit interrupters, or SIs. SIs are devices that protect people from electrical fires. They work by monitoring the current flowing through a circuit for the characteristics of an arc fault. An arc fault is a dangerous electrical condition that can cause a fire. Arc faults can occur when there is a break in the insulation of a wire or when there is a loose connection. The NEC requires that SIs be installed in certain locations, such as bedrooms. SIs are designed to detect arc faults and trip the circuit breaker, which de-energizes the circuit and prevents a fire. SIs are more sensitive than standard circuit breakers and can detect arc faults that standard circuit breakers cannot. It is important to test SIs regularly to make sure they are working properly. SIs can be tested by pressing the test button on the device. If the SI trips, it is working properly. If the SI does not trip, it should be replaced. In addition to SIs, it is also important to use surge protectors. Surge protectors protect electronic equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage electronic equipment. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. Surge protectors work by diverting excess voltage away from the electronic equipment and into the ground. Surge protectors are available in a variety of different types, including whole house surge protectors and plug-in surge protectors. Whole house surge protectors are installed at the electrical panel and protect all of the electronic equipment in a house. Plug-in surge protectors are plugged into individual outlets and protect the electronic equipment that is plugged into the outlet. It is important to choose the correct type of surge protector for the application. The surge protector must be rated for the voltage and amperage of the circuit. It must also be able to handle the maximum surge current that is likely to occur. It is also important to replace surge protectors regularly, as they can wear out over time. Surge protectors typically have a limited lifespan and should be replaced every few years. When working with electrical wiring, it is important to be aware of the different types of electrical boxes. Electrical boxes are used to house electrical connections and devices. There are many different types of electrical boxes available, each designed for a specific purpose. Some common types of electrical boxes include metal boxes, plastic boxes, and surface mount boxes. Metal boxes are typically made of steel or aluminum. They are strong and durable and can be used in a variety of different applications. Plastic boxes are typically made of polyvinyl chloride or PVC. They are lightweight and corrosion resistant and are often used in damp locations. Surface mount boxes are designed to be mounted on the surface of a wall or ceiling. They are often used in applications where it is not possible to install a recess box. It is important to choose the correct type of electrical box for the application. The electrical box must be large enough to accommodate all of the wires and devices that will be installed in it. It must also be suitable for the environment in which it will be installed. For example, a plastic box should be used in a damp location, while a metal box can be used in a dry location. When installing electrical boxes, it is important to follow all NEC requirements for box fill. Box fill refers to the maximum number of wires and devices that are permitted in an electrical box. The NEC specifies the requirements for box fill in Article 314.16. This section provides the rules for calculating the volume of an electrical box and the number of wires and devices that are permitted in the box. The volume of the box is determined by its dimensions, and the number of wires and devices is determined by their size and type. For example, each wire that enters the box counts as one wire. Each device, such as a switch or receptacle, counts as two wires. The total volume of the box must be sufficient to accommodate all of the wires and devices. If the box is overfilled, the wires can overheat and cause a fire. When making electrical connections, it is important to use the correct type of wire connectors. Wire connectors are used to join two or more wires together. There are many different types of wire connectors available, each designed for a specific purpose. Some common types of wire connectors include wire nuts, push-in connectors, and crimp connectors. Wire nuts are the most common type of wire connector. They consist of a plastic cap with a threaded metal insert. The wires are twisted together and then inserted into the wire nut. The wire nut is then tightened to secure the wires together. Push-in connectors are a newer type of wire connector that is becoming increasingly popular. They consist of a plastic body with spring-loaded contacts. The wires are simply pushed into the connector, and the spring-loaded contacts make a secure connection. Crimp connectors are used to join wires together by crimping them with a special tool. They are often used in automotive and marine applications. It is important to choose the correct type of wire connector for the application. The wire connector must be rated for the voltage and amperage of the circuit. It must also be compatible with the type of wires being used. For example, some wire connectors are only approved for use with copper wires, while others are approved for use with both copper and aluminum wires. It is also important to make sure the wire connector is properly installed. The wires must be properly stripped and twisted together. The wire connector must be tightened to the correct torque. And the wire connector must be protected from moisture and corrosion. Also consider the use of conduit. Conduit is a tube or trough used to protect and route electrical wiring. There are several types of conduit, including rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or aimed flexible metal conduit, or FMC, and liquid-type flexible metal conduit, or LFMC. RMC is the heaviest and most durable type of conduit. It is typically made of steel or aluminum and is used in applications where the wiring is exposed to physical damage. IMC is a lighter weight version of RMC. It is also made of steel or aluminum and is used in applications where the wiring is exposed to moderate physical damage. EMT is the lightest and least expensive type of metal conduit. It is typically made of steel or aluminum and is used in applications where the wiring is not exposed to physical damage. FMC is a flexible type of metal conduit. It is used in applications where the wiring needs to be bent or flexed. LFMC is a liquid-type version of FMC. It is used in applications where the wiring is exposed to moisture. The choice of conduit depends on the specific application. Factors to consider include the type of wiring being used, the environment in which the conduit will be installed, and the degree of physical protection required. When installing conduit, it is important to follow all NEC requirements for conduit installation. The NEC specifies the requirements for conduit support, conduit bending, and conduit connections. Conduit must be supported at intervals specified in the NEC. This helps to prevent the conduit from sagging and becoming damaged. Conduit must be bent using special bending tools. This helps to prevent the conduit from being damaged or crushed. Conduit connections must be made using approved fittings. This helps to ensure that the connections are secure and watertight. When pulling wires through conduit, it is important to use a wire lubricant. Wire lubricant helps to reduce friction and makes it easier to pull the wires through the conduit. It is also important to avoid overfilling the conduit. The NEC specifies the maximum number of wires that are permitted in a conduit. Overfilling the conduit can make it difficult to pull the wires through the conduit and can also damage the wires. Remember to always consult the NEC and local electrical codes for specific requirements and regulations related to electrical work. Safe electrical practices are crucial to prevent accidents and ensure the proper functioning of electrical systems.